India's space journey enters a new era today. Hyderabad-based private space company Skyroot Aerospace launched its Vikram-1 rocket on Mission Aagaman from the Satish Dhawan Space Centre in Sriharikota. The launch marks the first ever orbital launch attempt by an Indian private company using a launch vehicle developed outside the government space program. It is being seen as a landmark moment for India's rapidly growing commercial space sector. Now, the 7-story tall Vikram-1 launch vehicle was successfully completed all the final checks ahead of the liftoff, though there was a small pause in it. But they completed the checks and it was launched. The rocket attempted to place multiple technology payloads into the 450-kilometer low Earth orbit at 60-degree inclination, demonstrating the capabilities of India's private launch ecosystem. Now, built with an all-carbon composite structure, Vikram-1 can carry payloads weighing up to 350 kilograms. The launch vehicle is powered by indigenously developed propulsion systems, including advanced 3D printed rocket engines and high-thrust solid rocket motors.
And you see wonderful views of S3 separating. And now we have...
In fact, now we are joined in by Group Captain V.N. Jha, who's a retired senior scientist and former Joint Director with DRDO, who joins us. Professor V.N. Jha, you know, a lot of firsts when it comes to the Vikram-1. For me, the most interesting aspect of it is that they have used a 3D printed engine to, in fact, look into the component of its launch. How significant do you think is that 3D printing technology is now getting incorporated with regards to high important missions like this one, like the Vikram-1? How do you in fact see this? And on the other side, when it comes to private players in the space sector, Skyroot has its first launch. Do you think many such entities will emerge in the coming years? Professor, can you unmute your...
I'm sorry. Yes, there is no doubt that many new things, new innovations, new approaches are going to emerge in the private sector, because they don't have the liberty of free flow funds where they can, continue endlessly. And in this particular technology, in this particular effort of Skyroot, I've been, involved in commenting their various tests and facilities right from the, 2021 June, when they had conducted the first third stage motors burn flight, in which they had measured their total thrust, and they calculated whether they will be able to achieve the orbital velocity or not. So from that time onwards, then November 22, they tested the first stage. March 24, they tested the second stage of the motor. So I have been aware of what is going on with the Skyroot, and I also have been involved with the new step or new approach being taken through printing of the parts. I'm not against it, but I hope there is some amount of quality assurance being kept with this 3D printed components, whether subsystem, system, or hardware, whatever hardware they are creating. I hope it is tested, it is certified by some agency, and the QA is being, quality assurance is being very strictly maintained about it, because today's success puts this Skyroot straightway for the another launch or commercial launch. I hope during the process of launching the rocket, all the subsidiary systems and subsystems which have got any input to the room from where it is being controlled, it gets that feedback in flight as well as after deployment into the desired orbit as to how the functions of those components which were 3D printed behaved under those circumstances, because there are numerous variables which come into play, right from pressure, tension, the loads, the temperature. You can continue counting like this. So how all these behave during the process of launch when it is under the G loading, and how it behaves when it is left into the orbit without any G-loading. So that is one aspect that I will be keenly watching how Skyroot approaches this 3D printed materials and takes some way of certification by the independent agency and then thereafter maintains the QA. That is one thing. Secondly, hearty congratulations to Skyroot. And more than that, I congratulate the government of India having taken such a step of promoting the private players to go for such adventures. Now ISRO should be free to do its R&D for the value additions, for the bigger projects, for the bigger jobs. That is what is lacking for quite a long time. After we had developed the GSLV-3, and the same thing is as LVM-3 as well. We haven't gone for much of the payload carrying capacity. All these have got the payload carrying capacity of about 8 tons to the LEO. Uh, God knows if it goes to the GTO or GSO and how much load it carries. There is a need. You have straightway say SpaceX. It has got a Falcon rocket, Falcon 9 rocket. It has got. It can carry 21 tons of load, and that is in every day-to-day competition that ISRO will continue facing in commercial launching, since there's a requirement of deployment of tens of thousands of satellite for various constellations. So from looking from that point of view, I think it is a marvelous step by Skyroot. And in the coming time, there are others as well who are going to come in this, whether it is Skyroot, Agnikul, Pixel, Vista, Dhruva, and there are numerous many other in the pipeline. So great achievement by Skyroot. Compliment the entire young team and compliment government of India to have taken such a step. And we are only going to see the increment of their capabilities in the coming time. Agnikul, I suppose, is also ready with some amount of technical demonstration. So all these are going to come in the subsequent times, Varghese.
One clear aspect of it is that when it comes to new material technology, this rocket has used a lot of carbon composites. Now, initially it would have been aluminum alloys and alloys that, ensured the traditional rocket motors. They all relied on a kind of light metals, but that is moving into composites, especially carbon composites. Do you think carbon is the new gold when it comes to material that we are going to see being used more in rockets?
Nothing new. We knew carbon composite, carbon-carbon bond for a fairly long time. DRDO has used it a long time back, after which it offered to ISRO for using as a re-entry vehicle. So we are aware of that. And in the testing of their motors, third stage motor in March 2024, this came for discussion. Now, since Skyroot has got this carbon-carbon composite, either providing a casing or giving some sort of coverage to the payload section, that carbon-carbon composite will make it very, very accurate and adequate for re-entry. Remember, when the vehicle re-enters at that 17,000 miles per hour, 27,000, some 500 odd kilometers per hour. The temperature is in the region of plasma, 2,400 degrees Celsius to 2,800 degrees Celsius. And in that time, this carbon is the one which will sustain every sort of thing. Right now, there are other materials as well, including ceramic and few more. So I thought possibly Skyroot is thinking in the terms of reusing this particular stage. But today, when we went in the details of it, presently they are not thinking of. But then this is a positive step. If carbon casing they are using, they might as well use it for the reuse purpose if they recover it intact without much of harsh landing deceleration forces. If the impact is smooth, they can use it in the coming time. But there are many things, many questions arise from here. Today, I was keeping my fingers crossed because there's one particular aspect that all these satellite launching vehicles must achieve, and that is the orbital velocity. For deployment at 4,500 or 400 450 kilometers or 400. We need an orbital velocity, absolute orbital velocity of in the region of 7.5 to 7.6 kilometers per second. And if it is less, there is a chance of all those satellites which is being carried out to fall on the ground. SpaceX has done it at least twice. One is before the public eye for the entire world, and second one they tried to hide that they were unable to achieve the orbital velocity, but it has happened twice. So that is one thing I was very keenly watching, and I'm glad that orbital velocity was reached much well in advance. I think they had a few kgs of fuel left at the end of it, which they will be using subsequently. So compliments to Skyroot, compliments to the design team, and compliments to the entire thing. Not it is not this particular thing is proven. This particular mark of the rocket is proven. Value additions can continue, and they have already in plan. I think there's a second stage of rocket which can carry double the loads. That also is coming up there. So wish them the very best of luck, and if they continue in this way, but but go on a very scientific way. 3D printing is absolutely fine. If you have proven that what product has come out withstands all those specifications, what is required
Right.
for the launches. So wish
Right.
them all the best. Wish the entire team and the government for the first achievement. It is the first of kind in our country.
Right. Thank you, Group Captain Wayne Jha, for in fact giving us a perspective on this particular historic moment for India's private sector.